Hi, Catherine. So I'm just going to run down the two questions that we were looking at. So the first one is 5C on page 230 in the textbook. And so basically what you're given was the 4j minus 2 squared, and then minus 2 plus 4j squared. Okay, so we kind of talked about this a little bit, but basically what you want to do here if you're trying to factor it is, even though we have like a more complex thing here than just a number, we can basically think of this as being the same thing as if we had like, say, like 9x squared minus 16, right? So you would look at both of these and know 9 is a perfect square, as is x squared, and so is 16, right? So basically, if we wanted to factor this, we would go the square root of 9x squared is going to be 3x, and then the square root of 16 is going to be 4. And so basically, our factored version of this expression is going to be a combination of these two why am I blanking on this? Not expressions, but terms. There we go. So it would be like these two terms together in a bracket. But remember, in order to have this expression where we have no middle term that has like a number value and just x, that means that we have to have a positive and a negative version of our last term so that they cancel out. So basically, you're going to have 3x plus 4, and then in the second bracket, you have to have 3x minus 4, right? And that way, if you multiply them all out, you'll have like 3x times by negative 4 plus 3x times by 4. So you'd have negative 12x plus 12x, and that cancels out, so you have no middle value. And then in the end, you would just have positive 4 times negative 4, which is going to give you negative 16. So basically, we can do the same thing with this term, where because everything in this bracket is squared and everything in this bracket is squared, both terms are perfect squares. And so all we need to do is square root each of them. Okay, so essentially we're going to have square root of 4j minus 2 squared, which of course basically just removes the square, right? So we have 4j minus 2. And then for the second one, square root of 2 plus 4j squared. And when we square root that, we're going to have 2 plus 4j. So now, just the way we would for like a kind of more standard perfect square, we need to have the first term plus the second term in one bracket, and then the first term minus the second term in the second bracket. So this ends up being kind of weird because we have like larger terms. It's not just like one term, it's actually like a small expression for each of them. So essentially what we're going to have is 4j minus 2, right? That's like our first term here, plus our second term, so plus 2 plus 4j. Okay, so all of that is together in our first bracket. And then in our second bracket, we're going to have our first term, so 4j minus 2. And instead of plus this time, we're going to have minus our second term, which is 2 plus 4j. Okay. All right, so that's everything in there. Now the next step that we have to go through is to simplify. So basically, within each bracket, like just the way here we wouldn't multiply through the brackets, but we make sure that we have each term in its simplest way of expressing it, right? So basically, same thing here. We want to combine like terms. So 4j plus 4j, right? So just combining the two things that are the same gives us 8j. And then negative 2 plus 2 gives us 0, so we have nothing else in that bracket. And then in this one, we have 4j minus 4j, so that's going to be 0. And then we have negative 2 minus 2, which gives us negative 4. Okay. So yeah, there's our simplified expression. And if you remember, we talked a little bit yesterday about how, like, if you go through it in another way, you end up with 32j. But just like with this one, we do actually want to keep these two separate. So this should be our final answer. So yeah, just try and remember to follow through the same set of steps there as we would for any other perfect square. Or, sorry, I guess difference of squares, because normally we use perfect square for perfect square trinomial. Okay, so that was 5c. Now the other thing, that question 6c that we were looking at, that we couldn't figure how they got the last part, I actually consulted with some other teachers, and we all found that the end answer in the textbook is incorrect. So I'll walk you through how to get to the correct kind of answer, which is in the textbook, but they basically, what they did in the textbook solutions is they took it one step further, but they didn't account for factoring out this 1, 2. And so basically, like if you look at your solutions, the very last step is like shouldn't be included in there. So really quickly, the question that we had here for 6c was -1/4 times by 2x squared plus 25 2y cubed squared. So one thing that's kind of unfortunate about this question is if this wouldn't have been a negative, then both of these terms would have been perfect squares, because 1/4 is a perfect square of a half, and 2x squared is can be square rooted to 2x, right? And same thing, 25 could be square rooted to 5, and 2y cubed squared could be square rooted to 2y cubed. So then if this would have been positive 1/4, we could have treated it the exact same way we did in the previous question. But because it's not a perfect square here, we have to basically work through and start out by trying to factor out the coefficient for the first term, right? For our x squared term. So essentially what we're doing then is we are dividing out -1/4 out of this whole expression. So that we put that out front, -1/4. Also another thing to maybe point out as we're going into this is that all the teachers that I talked to agree that this would be like a very high standard of excellence question. So if it's still kind of messing with your head a little bit, don't be too stressed out about it, because this would be like considered like the ultimate pinnacle kind of question on a test. And usually we don't give many of those. Okay, so -1/4, if we factor it out here, then we're going to be left with 2x squared plus 25 divided by -1/4 gives us -100, because it's the same as multiplying it by 4, right? Dividing by a fraction is the same as multiplying by the reciprocal. Okay, so we have -100, and then we'll keep this 2y cubed squared. Okay. So all of that is multiplied by -1/4. So then the next thing that we would want to do is now we do have two perfect squares in here, right? Because we've gotten rid of this -1/4. This can be square rooted to just 2x, and this whole thing can be square rooted because 100 can be square rooted, and so can 2y cubed squared. So we're going to end up with -1/4 bracket 2x, now that we've square rooted that, minus sorry, I put in plus negative here, when really we could just write minus. So I'll just get rid of that. Okay. Although it is the same as plus negative, but whatever. So 1/4 times by 2x. Wait, I didn't want to put a bracket there. 2x minus square root of 100 is 10. And then 2y cubed square rooted is 2y cubed. Okay. There we go. So basically what we're doing here, though, is the same as we were looking at in the previous question, right? So if we square root the first term and we square root the second term, and we subtract them, then in order to factor them, remember we want to have another bracket where those square rooted terms are added together. So we're going to multiply this bracket by 2x plus 10 times by 2y cubed. And another bracket there. Okay, now again, like we did up here, we want to simplify, right? So basically the only way we can do that is to multiply these two brackets together. So negative a quarter stays outside, and we have 2x minus 10 times 2 is 20y cubed. And then over here, 2x plus 10 times 2 is 20y cubed. Okay. So this is basically where we should be ending up at. What they did in the textbook was essentially they divided it out to get rid of this coefficient. But the problem with what they did is I don't know how to exactly explain this, because basically what we have here is the same as if we had negative, because basically we're multiplying this fraction by these terms. So it'd be like negative 1 times by all of this. So we have negative 2x minus 20y cubed divided by 2x plus 20y cubed. And then the 4 is on the bottom, right? So technically what you could do here is, because all of these have factors of 2 in them, you can take the 2's out, but that doesn't reduce this 4 down to nothing, which is what they did in the textbook. So essentially what you should end up here with, if you divide out the 2's, is you'd have like x minus 20 divided by 2 is 10y cubed, and then 2 divided out is leaving us with x plus 10y cubed. Right, but that's only taking out, like, if we think about this as being like 2 times 2 here, we've divided out one of those 2's, and we're still left with a 2 on the bottom there. Sorry, I was out of the screen there for a second. So this is where I would expect you to leave it, or let's see. Yeah, I would probably, in a question like this, hope that you would carry this through. But again, because this would be such a challenge question, you would still get most of the marks for getting this far. And then, yeah, if you extend it that far, that would probably be worth like an extra half a mark or so. Okay, so hopefully that helps you understand those questions. And yeah, good work on the chapter so far.